I'd like to thank you all for joining us today for our webinar, Precision in Motion. My name is Jason Taylor. I head up the mobile mapping group for Seiler Geospatial. I'm based out of our Kansas City office. And our team here at Seiler, we cover 9 states throughout the Midwest, supporting all of our mobile mapping customers. So I'd like to welcome everybody from our region of the country and anyone else that's joining from outside of that area. This webinar is part of a larger mobile mapping series that we've been working on over the last several months, titled Beyond Corridor Mapping, where we've highlighted some of the emerging applications and workflows that go beyond your typical highway corridor design type project. So with the advancements in our hardware solutions, as well as some of the emerging applications that are possible now thanks to the software, we wanted to highlight some of the revenue streams and potential applications that are possible now. So one of the applications that we highlighted in this case study was pavement inspection. And so the tools that are now available in Trimble Business Center have opened up a whole suite of tools just specifically designed for that. So we're really happy and fortunate to have with us today Christina Bezberdova, who is the product manager for feature extraction at Trimble, who's been heavily involved in that process. And we also have Skylar Newmeyer, who's the mobile mapping application engineer at Trimble, who is an expert when it comes to all of the systems and every application under the sun. So we're very fortunate to have them with us today. And we're going to be kind of doing a deep dive into that pavement inspection workflow. So just one note, for those of you that haven't checked out the case study, we do have that available in the handout section here in the webinar. So feel free to download that, check it out. There's also a great series of videos that we have as well. So again, thank you all for joining. Okay, so agenda today, we're going to start out. I'm going to do a run through on our mobile mapping portfolio, and then we're going to hand that over to Christina to cover the pavement inspection in TBC. And then lastly, Skylar will take control and we're going to do a live demo of that workflow in Trimble Business Center. So Trimble's mobile mapping portfolio. As it stands today, we have 3 systems. So our flagship system would be the Trimble MX90. It's kind of our do-it-all, meets every spec that you would be looking for. In the mid-range, we have the Trimble MX90. Both the Trimble MX90 and MX60 are relatively new releases that came out in 2024. So the Trimble MX90 replaced the previous iteration, the Trimble MX9, and the Trimble MX60 replaced the Trimble MX60 replaced the MX50 platform. And then all the way on the left, we have the Trimble MX7, which is an image-only sensor, more for kind of customized Google Street View type applications. The Trimble MX7 is being sunsetted at this point, so we've got our fingers crossed that we'll have a new solution to kind of fill that space, hopefully in the next calendar year. So we'll start out taking a look at the Trimble MX90. So here's a system overview of the Trimble MX90. So we can see on the right the system components. One of the very popular things that we found with customers with both the MX90 and MX60 is the simplicity of the system. So on the left-hand side there, those are the 3 main components of this mobile mapping system. So we have the sensor unit, which houses the lasers, image sensors, all of the nav components. And then We have a control unit, which acts as basically the computer for the entire system during data collection. All of the data is written to hard drives that are stored on the control unit. And then we have the power unit, which is regulating power to the system. So it's very simple. We have a one cable connection that goes from the control unit to the sensor unit. Setup is quick, easy. Customers can typically be trained to operate the system in a day. So as we kind of look down the list on the right, we have our field software, which is TMI, Trimble Mobile Imaging. That field software is utilized for both the MX90 and MX60. And then our office software, Trimble Business Center. So we'll be looking at Trimble Business Center when Seiler takes control here shortly. But Trimble Business Center, there's a number of different modules there depending on the type of workflows that you're looking at. Most of what we're doing takes place in the mobile mapping module of Trimble Business Center. We're now capable of doing a field to finish workflow in TBC. So we've combined the functionality of a Planix POS pack into Trimble Business Center for trajectory processing. So there's no longer a need for multiple software suites to process all of this data. So that's been huge for our customers. So just want to touch on a handful of specs related to the MX90. As I mentioned, the MX90 is Trimble's top tier system. So we've got the highest point density, highest range as far as the lasers are concerned, the largest camera array out of the systems that we have available. So just to kind of highlight a couple of the specs that we have here, the maximum measure rate on the MX90, we can collect up to 3.6 million points per second with this system. So that's a staggering amount of data. Most customers, and when we are showing these products to customers, we typically scale that back, but you do have the flexibility to run it that high, which enables you to travel at higher speeds and not be concerned with data density. So 3.6 million points per second. We have a 360 camera on both the MX60 and MX90. So on the 90, we have the current generation Ladybug 6 camera, so 72 megapixels on that camera. And then the MX90 also has 3 planar cameras. So 2 forward-facing adjustable cameras, and then also a downward-facing pavement camera. So now we have the MX60, again, released in 2024. Similar to the MX90, the MX60 has very similar components. One of the things that we like to point out to our customers, all of these components are the same. So if you have a vehicle that's set up for an MX90 or an MX60, it can accommodate either system. We do offer an option to our customers that own MX60s. If they ever do have a project that requires some of the additional specs that the 90 offers, we can rent that system to them, and it'll plug and play with their MX60 setup, which is great. So everything's the same here. We've got the sensor unit, control unit, power unit, and then same operating software and same processing workflow as I mentioned for the MX90. So one key point on the MX60 is that we have 3 separate versions of it. Trimble has switched or is adopting kind of a product lineup naming convention where we have Core, Pro, and Premium, and that's reflected across a number of different product lines. But here at the MX60, Trimble did a really great job of creating 3 separate platforms at the MX60 level that offer different levels of performance and different price points. So they've made the core and a very affordable entry-level price point into mobile mapping, all the way up to the premium that is spec'd very similar to the MX90 as far as accuracy is concerned. So this chart kind of lays out the differences between the systems here. So the MX60 Premium is available with an AP plus 60 IMU, which is the highest grade IMU available from Applanix currently. That is the same IMU that is in the MX90 system, where the MX60 Core and the MX60 Pro are using the AP plus 50 system, or plus 50 IMU. The plus 50 IMU is still a great option and performs very, very well. When we come to the camera options, we've got a couple different options there. So the Pro and the Premium are using that current generation Ladybug 6, where the Core has the Ladybug 5 Plus. So it's the previous generation panoramic camera, lower megapixels with that. You're looking at 30 megapixels versus 72. But again, you're getting an entry-level price point there. All three systems are using the same profilers. So we're using the X9P lasers on all of these systems. And all three systems have the back down camera, which was a huge improvement over the previous iteration MX50. So touch on a couple of the specifications for the 60. So the MX60 is capable of doing up to 2 million points per second. So not quite the density that the 90 was capable of, but just to put it in perspective, the MX60s at 2 million points per second is the same as what we were able to achieve with the first generation MX9s. And we're doing that at a much, much lower price point. So the bang for your buck on the MX60 systems is pretty high. So 360 camera, as I mentioned, we have a 72 or 30 megapixel, depending on what you're going for. And then we have just the one planar camera, which is that downward back-facing camera.
Thanks, and so Skylar here, I'll jump in on this slide. So this just is kind of a good point to discuss the differences between a 90 and a 60 and what might cause you to go one way or the other. So on this slide, we've got kind of the breakdown of the physical components, but a lot of the way I kind of focus this conversation is what is your workflow, what kind of data are you collecting, and then let's work backwards into which sensor fits that better. So if anybody has any questions or chat messages, now's a good time to drop them in the message board that we can touch on the hardware. But a couple kind of key questions on the MX60 versus MX90 comparison is simple stuff. How much data do we actually need? What kind of point density are we targeting? What kind of environmental conditions are we going to be collecting that data in? Are we always going to be in a heavy canopy where in South America, we've got customers in Brazil, they're dealing with a lot of heavy canopy every day? Or are you out in Kansas and you've got pretty open skies a lot of the time? You're going to have good GNSS signal a lot of the time. And then the third question is what are you using the 360 panoramic images for? That's where we kind of help people differentiate between the Ladybug 6 and the Ladybug 5 Plus. Are you wanting to just use it as a custom Google Street View and kind of get an overview of your area? Or are you actually trying to read signs, read license plate kind of size text, maybe pole tags on a power pole? Do we actually need that additional resolution for parts of your workflow? So those three questions of point density, positioning, accuracy, and conditions, and what we're using the imagery for are kind of where I would usually direct somebody to a certain system. For the particular workflow that we're discussing today, the pavement inspection workflow, now that we added the downward-facing pavement camera to the MX60, you have plenty of options, and even a core MX60 is quite capable for this workflow. While the previous gen systems, we only had the pavement camera on the MX9, the highest end option. We got quite a few requests saying, I want this workflow, but at a lower price point. So we listened and added that camera, and now you can do this workflow with any of your options. And unless there's any questions or chat messages, I will pass it over to Christina to talk more about the specific workflow we're focusing on today.
Yeah, so products like mobile mapping on the hardware side, software, Trimble Business Center, asset lifecycle management platforms like AgileAssets, Trimble Unity. This enables us to create an entire ecosystem for transportation asset management. For every asset, we will talk more about pavement today, but of course, you already know that you can also use the same hardware and software platform for other assets in your transportation corridor, beyond pavement, traffic signs, guardrails, all that can be extracted as well. So this ecosystem serves all the transportation assets and every stage of every asset's life cycle. And this ecosystem spans from field data collection with mobile mapping systems to feature extraction, Trimble Business Center, and now Trimble Business Center seamlessly integrates with the Trimble's asset lifecycle management platform, AgileAssets Pavement Analyst, and we're working on integration with the Trimble Unity as well. The mobile mapping and processing in Trimble Business Center, this creates a single source of information, single source of data for all the teams within the organization. It serves planning, design, construction, operation, maintenance. You collect data once, you reuse it multiple times for different teams, for different assets. The great part about the mobile mapping data and about the processing in Trimble Business Center is that the data accuracy and the extraction accuracy, they are sufficient for every stage of asset life cycle. With the design having the most strict requirements for the data and extraction accuracy and precision to GIS applications or operation maintenance where you require a little bit less of accuracy and precision. So for public agencies, this workflow can be quite attractive due to a number of reasons. First of all, we enable a seamless data flow within an organization. Our hardware platforms and software platforms are integrated, and we have direct communication between Trimble Business Center. We have integration with ASRI. We have interoperability with Autodesk and Bentley. Now we integrate with the AgileAssets Pavement Analyst. And again, this data can be used for any team within the organization, from design to operation, maintenance, and for every asset in the transportation corridor, not just pavement. But of course, pavement is one of the most expensive assets, so one of the most interesting assets to monitor and make sure that its life cycle is long. And now, where does the Trimble Business Center stand in the pavement inspection workflow? So we collect the data with the Trimble MX systems, right? We collect the point clouds and we collect the images. So what we get is points and pixels, right? But then we have asset lifecycle management systems like Trimble Unity, like AgileAssets. We also have our databases like ASRI. This systems, ASRI database, or your asset lifecycle management platform like Trimble Unity or like AgileAssets, they cannot consume point clouds and images. They do not need points and pixels. They need information about your asset. And that's where you have Trimble Business Center and its pavement inspection workflow that can transform your points and pixels into valuable information. So basically, you get the data from MX system, you transform it to information with Trimble Business Center, and this information can be later on be consumed by your asset lifecycle management platform, You can use it in your databases. You can give it to your field teams and so on. So we start with the field data collection here, and Jason Seiler talked about it, right? The mobile mapping data collection is the most suitable way of data collection for transportation asset management and for pavement management. You mount the system on a vehicle, you can collect data at highway speeds. The data is very accurate, very precise, and you have different sources of data, right? You have your cameras, so you have your 2D imagery, you have your point cloud data for 3D information. Optionally, you can mount a GPS sensor on the same vehicle to collect the utilities as well, or subsurface. And of course, because you don't have to be in the active traffic, you keep your employees safe, right? So you don't need to go outside and to verify pavement condition. You can sit in your car, collect the data, come back to the office and process this data. No need to be in the active traffic. You can also avoid road closures. Again, you're just on the highway in your vehicle, you're just driving, collect the data. No need to close the road to inspect pavement and to evaluate its condition. So after you collected your data, it's great, right? You collected your data very quickly. You can collect at the speeds of 60, 70 miles per hour. So you have your point clouds, your images, you're coming back to the office, and you have large point clouds, terabytes of point clouds, you have tens of thousands of images. Now, what do you do with it, right? Because you actually need not the point clouds and images, you need the information that you can extract from this point clouds and images. And that's where Trimble Business Center's pavement inspection workflow plays a big role. We have a workflow that can automatically identify any type of pavement distress. It can classify it, and it can evaluate the severity of each distress based on geometric attribution that we can extract from imagery and point clouds. The analysis is based on pavement segmentation that can be prepared in the third-party software. Maybe you have Esri roads and highways, and you would like to use your road network segmentation from there. Maybe you would like to send your road segmentation from AgileAssets or any other asset lifecycle management platform. So Trimble Business Center can take this pavement segmentation as an input data, overlay it over your point clouds and images, and perform analysis based on the pavement segmentation that you prepared in the third-party software for pavement data or pavement information management. Or we can also segment the road for you. We can also automatically segment the road based on user-defined sample unit size and segment size. And this pavement inspection workflow in Trimble Business Center, it's suitable for various workflows. It can be post-construction inspection. It can be the pre-construction inspection. It can be the QA/QC of your data vendor. Let's say if you have a third-party vendor who provided you with the results of pavement inspection for your road network, and you would like to do the QA/QC, you can use Trimble Business Center to verify this this information that you got from a third-party vendor. Or you can assess your network as well with the same workflow. So it's suitable for different configurable workflows. Now, how do we do this? How do we automatically identify, classify, and evaluate the severity of each pavement distress of your road network? First step is, of course, ground isolation. We have automated point cloud classification that can classify your point clouds into different classes, into different point cloud regions. Can be traffic signs, guardrails, vegetation, poles, power lines. But for this specific workflow, of course, what's most important is to isolate the ground, because pavement is a part of the ground point cloud region. So you can run this point cloud classification. You will get your ground clean and ready to run the analysis on. You can isolate your lanes for analysis as well. We have tools that can automatically extract striping from your mobile map and data. Again, it's very easy. You just select the trajectory that you would like to use for lane line extraction, and we will automatically generate striping of design accuracy based on the input data. And we can classify the striping as well. And another important part of this workflow is the ortholane. So the pavement camera collects the imagery of the pavement, and that's what we use for crack detection. But the pavement camera has a perspective effect. So it does not look at the pavement at 90-degree angle, meaning that if you try to calculate or measure the crack width or crack length based on this type of imagery, it won't be accurate at all. So what we actually do, we apply orthorectification to pavement imagery, and we mosaic this imagery, and this orthorectification process ensures the accurate crack measurement. Next step is the road segmentation. So usually if you work with a public agency, or if you're at a public agency, you would like to analyze your road and return the analysis results per segment. So you would like to assign all the distresses that you found on your pavement to specific segments of your road network. And that's why we have a mode in pavement inspection that allows you to add your own road network to Trimble Business Center. So Trimble Business Center can return the analysis results based on the segmentation that you provided. Or as I mentioned before, we can automatically segment your road based on user-defined sample unit area and segment length. Segmentation is also very important because if you analyze large sections of the road, it's still too much of information. Let's imagine you analyzed 10 miles or 100 miles of road, and you get vectors for every pothole, every crack. But how do you know which part of your 10-mile road is the worst? What part of your road needs the most attention? This segmentation allows you to look at smaller chunks of your road network, so you know which parts require your attention today, or in 2 years, or in 1 year, and so on. So again, you can use 2 segmentation modes in Trimble Business Center. The pavement analysis can be done based on automated segmentation or based on pavement segments that were prepared in third-party software. So if you're not familiar with the road network concept, road network is an entire inventory of roadway that transportation agency is responsible for managing, inspecting, and maintaining. So road network is broken down into smaller, manageable units for practical inspection data analysis. And we link pavement inspection data, pavement inspection information to segments of the existing linear referencing system that is managed by a public agency in your region. Automatic analysis mode, where we automatically segment the trajectory and we create segments for you, can be still suitable for some projects, but usually if you're analyzing your road for a public agency, if this information later on will need to land in the asset lifecycle management platform, usually you would definitely be interested in the mode of the pavement analysis tool that allows you to input your own road network with your own segmentation. Now, how can you add your road network into Trimble Business Center? So you can use Esri feature service. So if your road network with the segmentation is stored in Esri, you can pull it directly from Esri. Trimble Business Center has GIS module that allows you to connect to your Esri feature service directly from TBC and pull the information from Esri feature service directly into TBC. Starting from November, we have a direct integration with AgileAssets Pavement Analyst. So if the pavement team prepared segmentation and the pavement segments that need to be analyzed in AgileAssets Pavement Analyst, you can pull it to TBC directly from AgileAssets. I will talk about this a little bit later, but basically you can just log in into your AgileAssets Pavement Analyst, and you can simply press a button, pull your road segments to Trimble Business Center, and you will see the segments that need to be analyzed in TBC. Or if you have your road network or your segments stored as a simple shapefile, you can just add the shapefile, and we will analyze your pavement based on this shapefile. So how does TBC finds or looks for pavement distresses? So TBC takes point cloud data from mobile mapping system, and it estimates the ideal road surface based on the actual road surface. We estimate this ideal road surface, and then we compare your point cloud, your actual road surface, to this estimated ideal road surface. And then we analyze whether we have points that are above or below the actual road surface. And that's how we see where we might have potential pavement distresses. Then we classify each distress. And classification of each distress is based on geometric configuration of the distress that we found. So once we found a cluster of points that is below or above the ideal road surface, this cluster has certain shape. So let's say it's elongated and it's located in the wheel path. So it's rotting, right? If the points are above the ideal road surface, it's a bump, right? If it's a series of kind of like depressions and bumps, we say, okay, it's corrugation. For correct detection, we're using imagery from Pavement camera. We trained a 2D deep learning model that can recognize cracking in the pavement imagery, and we classify the cracks into transverse, longitudinal, alligator cracking, and all the other types of cracking. Then, as I mentioned before, we ortho-rectify the images from the Pavement camera, and we actually measure width and length of each crack, or density of cracking for alligator cracking. And this ortho-rectification of Pavement camera imagery allows to ensure the correct width and length measurements for each crack. We can also calculate the IRI, so roughness index. While pavement inspection and PCI index is probably more interesting for those who are looking at the pavement before any construction, IRI might be interesting for those who are analyzing the pavement post repairs, post construction. Then you can actually find out how good the smoothness of your pavement is. And of course, for after we found all the potholes, cracks, we also can calculate the pavement condition inspection, pavement condition index score. We also have a direct integration with the AgileAssets Pavement Analyst. So transportation asset information is collected usually to enable planning, budgeting, and decision making. That's why the information about your potholes, about your cracks, about your depressions, bumps, and all the other types of distresses in your pavement, it usually lands in the asset lifecycle management platform, such as Trimble Unity or AgileAssets. Most of the states, some of the larger municipalities are using AgileAssets as their asset lifecycle management platform for pavement asset. And we created this direct communication between Trimble Business Center and Pavement Analyst. So hardware such as MX60, MX90 enables data collection. But again, how do we transform this data to information that can be consumed by asset lifecycle management platforms such as Trimble Unity, such as AgileAssets? That's where Trimble Business Center enables creation of meaningful deliverables, transforming data to information. So so we can create information that can be consumed by asset lifecycle management platforms that are used for budgeting, decision making, planning, calculation of different indices. So you collect data, TBC transforms this data into information about your pavement health, and then this information lands in the asset lifecycle management platform such as AgileAssets or Trimble Unity. The integration with AgileAssets Pavement Analyst implemented in Trimble Business Center is very easy. It is located in the mobile mapping module of Trimble Business Center and the inspect pavement condition command. You access Pavement Analyst from Trimble Business Center with your AgileAssets login. So you just open a window that allows you to input your AgileAssets URL. You enter your username, you enter your password, you log in into the system, into the Pavement Analyst directly from TBC. Then you can just press a button, pull a road segments, and all the segments that Pavement team prepared for you in the Pavement Analyst can be pulled directly into TBC, and TBC then can analyze the road based on the segmentation prepared in AgileAssets, and then you can simply send the analysis results back to AgileAssets. There are other ways to share information about pavement health. We have integration with Esri. You can send it to Trimble MX, or you can publish it to Connect as well. And with that, I'm giving it back to Seiler so he can show the software and how it looks like in the software.
Sounds good. Thank you, Christina. Alrighty, so we should have Trimble Business Center pulled up. So if you're not familiar with Trimble Business Center for doing your network adjustments or CAD work or other processing, it's our main flagship software. And I'll go through just a quick demo of a lot of the different tools, some of the results, everything that we've been covering in the slides so far today. So again, if you're familiar with it, great. You're used to using it for maybe traditional survey work. What we're really adding in for this type of workflow is just an additional module up here at the top. So, as you see, we've got point clouds or photogrammetry, or it's kind of, I think of it almost like a Lego kit where you can piece together different modules to create the ideal workflow for you without having to have a bunch of additional tools that you're not utilizing. So since today's webinar is focused on the pavement condition workflow, I won't really be covering some of the earlier steps, but just to give everybody some background, previous to this stage, we've defined our coordinate system, we've post-processed our trajectory against a permanent base station, we've aligned our two different passes down the road, colorized our point cloud, all that kind of preparatory processing of the mobile data has already been completed here. But we'll specifically dive over here into the Inspect Pavement Condition tool. And then this ortholane tool right next to it is kind of an associated or paired tool. So if we select a run or mission over here in Project Explorer and we open up ortholane, there's not too much to the tool. So you basically select a mobile mapping run, which a run is a collection of LiDAR and point cloud data. So as it's recording, you're recording a run where your entire project would be considered the mission. So you just tell the ortholane command which runs you would like to generate ortholanes for. And you can do multiple runs using the confirm batch command, or you can select the precise selection command so that you can do subsets of runs. So everything's organized based off the run structure, but you can do greater than a run or less than the size of a run too. The orthomosaic resolution, we are currently running 5 millimeters. You can generate smaller than that in some cases if you're just wanting to use the ortholane for other use cases, just maybe a background for a survey. You can also make a coarser, faster ortholane, but if the ortholane is going to be the input for your crack detection, we recommend leaving the default resolution there. So I've already run ortholane for this data set, and I'll show what those results would look like. It's a little bit of a cooking show switcheroo so that we're not sitting watching a progress bar while they're generating, but we'll look at the results here. And you can see it's quite a poor road. There's a reason I collected this data set, and the mission is called road damage, and it's to highlight a poor road condition. So most of your projects would not have as many cracks and defects as we're going to be looking at today, but it's no fun looking at a new road analysis with one pothole found. So once we've created these ortholanes, we can start moving on to our next step. So I've got my point cloud, and I'm going to switch over to a 3D view. so that you can kind of see the relief. We've got our power poles. I cut the range in here a little bit since the focus of today is on the road surface. I didn't need to generate a bunch of points out here, so I limited our range in, generated everything, and then we went to the point cloud module and said classify point cloud. So I've already classified it, and I'll switch over to that in a second, but I wanted to open up the command first. So the outdoor terrestrial model was used. The entire point cloud was selected with all classes and refinements. So I just opened this up to give you an idea of some of the current classes: ground, medium vegetation, high vegetation, buildings, poles, power lines. Noise is my favorite one because I used to spend a lot of time cleaning noise out of point clouds. Dividers, signs, and steps. And we're always looking to expand upon those. I see one of the questions in the chat is related to that, so we'll touch on that at the end too. So after classification, I'll switch over to represent the points by their classes. You see we've got, green for vegetation, red for poles, yellow for power lines. The one we're going to care about today is ground. So I'm going to just quickly turn all my regions off and turn just ground back on. One thing to keep in mind with the ground classification is it's important for a lot of this analysis, and having a good clean ground classification is one of the things I'm happiest with TBC doing, where in the past you might have had the bottoms of tires or little bits of noise. We can really strip everything out and get down to the bare asphalt. Alrighty, so creating our ortho lane and classifying and getting just ground are kind of our two main pre-steps to running inspect pavement condition. So if I open that command now, you'll see we've got the two modes. So analysis mode automatic is what we're going to look at today, and Christina's touched quite a bit on the road network mode. So road network mode, I would use these, this download road network command. I can log in to my AgileAssets URL with my username and password, and I could pull that previous road network information in as the input for the analysis. But just for today, we're going to run automatic because it basically can run with no prior information. So it doesn't need an LRS, so it kind of demos a little easier just by running standalone. But we are kind of seeing that I think most of the time when you're doing, road network level surveys, you would be in the road network mode. There's only specific use cases where we would want to generate fresh segments. A lot of times we're tying back into previous information. So the command has a couple inputs. So the mobile mapping run that we want to analyze is one of those. So we would just select our trajectory right there. And then the other one is the lane lines. So lane lines bound the area of analysis. And there's a couple commands right here. If you haven't already extracted your lane lines, you can directly open the lane line extraction tool from here. You can directly open the create line string tool from here if you want to manually draw some boundaries. Or another option that we found is for some customers that want to cover large areas, they don't maybe want to take the time to worry about exactly where the lane boundaries are. They'll take the vehicle trajectory and just offset it a set distance left and right and use that as the boundaries for their analysis. So that's also a valid option that's very quick if you don't need or care about the exact edges of your lanes being precise. So in this case, I've already got some lane lines. So I'm just going to switch back over to this view and get rid of my background map just to clean things up some. So I can click and then control click my other boundary. And you see this polygon highlights the area of analysis. We can analyze multiple lanes at a time if needed, but one thing to keep in mind is we can only analyze cracks for as wide as the ortho lane is covering. So if you're starting to analyze, lanes a lane or two over, you might start missing crack information on those. Then we've got some user parameters. So we've got sample unit size, sample segment length, a height depth threshold, and then this checkbox here says detect cracks, and then it gives you an option for back camera or ortho lane. Since we have ortho lanes generated for this project, we would want to use those so that we get severity info for the cracks and not just IDs of the cracks. You can run back camera and it'll run faster. You don't need to generate ortho lanes, but you'll just lack that severity info on your cracks. Another optional selection is Analyze Road Shoulder, which you have to give it a guideline to kind of give it an idea of where to search for the road shoulder. And as far as the PCI analysis goes, road shoulder is usually being analyzed for drop-off. So the idea is you don't want kind of a lip or a ledge on your road shoulder so that if somebody accidentally drifts over and gets off the road, it doesn't want to pull them or keep them off the road. So that is a component of the overall PCI if you're in a road area where you want to analyze that. So I'll uncheck that. We have some options in here for severity thresholds. So we can go through and select what size or tolerance for something like a pothole would be considered a high severity or a medium severity. One note though, is that if you go in and start editing these values, it's not technically PCI anymore. Since PCI is defined by an ASTM standard, these values have to be this to to meet that standard to accommodate its requirements. So you can change it. You can have your own severity levels. You could say only potholes over 3 feet are going to be high severity, but just keep in mind at that point it's a made-up condition index. It's not technically PCI, and then you can always use this button here to reset to the ASTM defaults if needed. The last kind of user options, you can decide which layer you're going to set the results on, but we can also filter out certain defect types. So we have seen certain niche cases where we analyze everything and then somebody, depending on maybe the remediation techniques they're planning, they only want to visualize the cracking, or they only want to visualize the most severe defects. So a lot of times, like you'll see on this road, once a road's really, really bad, whole segments basically show defects. So in cases like that, sometimes they only want to show the highest severity defects to kind of stop from losing that importance in a big old cluster of low severity. Alrighty, so all we would do now is click Analyze, and once again, instead of watching a progress bar for a couple minutes, I'll just switch over to the other lane. So I was just showing you how to analyze this lane. I'm just going to switch over to this lane and turn on some of those results. So once the analysis is done and confirmed, you'll now have this pavement condition inspection area underneath the feature extraction tree in Project Explorer. So if I turn it on, you'll see the different sample units. So these sample units are the ones that we generated. So since I ran the automatic mode instead of the road network mode, these are based on an area that I defined. Then the sample units, we can turn on and off any individual one here. We used to turn everything on, and then we kind of realized that if you were running 100 miles and suddenly turning on, 100,000 CAD objects would slow the software down. So for now, the sample units are shown. They're colored by their severity or by their score, and then we wait to visualize all of the defects in that sample unit unless you decide to turn it back on, so that they're not always all there. So if I right click on sample unit 20, I can visualize the segments. So the segments are those subset sizes of the overall sample unit. And then I can also click visualize conditions for sample unit and see all the actual defects found for this sample unit. So what I'm going to do now is I'm going to leave those conditions turned on. I'm actually going to turn the segments back off and really just focus on the defects that are being traced out. So then let's also go into View Filter Manager and remove the point cloud and take a look at things just on top of the ortho lanes. So you can see this kind of severe failure running through this this section of the road, and you see it's all bound by alligator cracking. We've also got transverse cracking, potholes, all kinds of things. And you'll see it ends here just because I'm not visualizing into the next sample unit. But this is a quick, quick check, quick QA. You can see we've got some bigger failure right here in red, which just means that part has dropped down lower. And that's what that'll look like. So then the next step that I would usually use in kind of taking a look at things would be going to the sample unit, and you can generate a heat map. So Christina mentioned how the deformation-based defects are really comparing to this ideal road surface. So the heat map can be generated to highlight what was really being analyzed as far as deformation-based defects. So turning the heat map on, and I can maybe bump the point size up a little bit, kind of highlights what that deformation-based model is seeing when it's analyzing and deciding what defects are there. So yeah, and this continues for the whole project. So basically I'm just showing one sample unit, but we have this for the whole project. Then we can also kick this out into a PDF report, or if we were running the road network mode, we would switch over, and instead of pulling that road network down, we would upload the pavement inspection conditions using this command here. Or I think it was also mentioned in the slides, we could have our GIS connection manager link into an Esri geodatabase and then run write features to GIS to push all that info into a GIS database. So you have three or four core options for getting this data out: putting it back into the ALM, going to some other database, creating a PDF report, or we can also create just an Excel report that allows you to kind of reformat it and change it however you'd like. Last thing I kind of wanted to show was just the 360 camera view and how that can be nice during some of your QA/QC process. So if I jump back over to plan view and then turn a few things on, go to run position, I'll jump my panoramic image over to this area that we're analyzing. And I can look at this on top of the 360, on top of the individual pavement camera. I can turn the image off, turn the point cloud on. We're pretty good at visualization options and keeping a lot going there. So I think that covers everything I wanted to touch on, is just a kind of a quick intro to what the workflow looks like. We'll take a few minutes and we can maybe touch on some of the questions that have come in, and if there's any additional ones, that'd be a great time to cover them. So there was a question on purchasing the hardware and if it includes the software, if it's a separate day cost. And then the question follows along with Jason's mention of a one-day training. What system would that be for, and does that include the software as well? So that's a great question. The hardware and software are separate part numbers, and that's considering TBC. That's the desktop software. So the field software, TMI, that you're actually running the system with, there's no license for that. There's no anything for that. It's just always with all the systems for no additional charge. But the desktop software, since there are different versions of it, they would be different line items on a quote. But I don't think I've ever really seen any quotes from any dealers that had hardware and not software. They usually just kind of go together on quotes, unless maybe you were purchasing a second system and already had the software in hand. For the training kind of varies depending on the user, their workflows, and their experience with TBC. So I have a lot of customers that are familiar with TBC, but maybe have only used it for network adjustments or some CAD work or traditional survey work, which still saves quite a bit of time because you're familiar in the software, you can navigate around, you can open a project. You might not need some of that basic training, and we'd really just be focusing on mobile mapping at that point. If that's not the case, and we're doing a complete intro to the software, we definitely spend more time in the software during a training than on the hardware. So it varies, like I said, but I think a common one is kind of the first day, the first half of the first day, we really focus on the field, setting up the system, collecting data. We'll start processing some of that data in the office that afternoon, same day as the collection. And then a lot of times that'll get us kind of to the point where I started this webinar. So you can maybe do some trajectory processing, scan generation, and then next day might be more specific to that customer's workflow. So are you going to be using it for GIS asset management? Then we might focus that second day of training just on your deliverables. So hopefully that answers some of that. And then the second question, it looks like the asker might have left, but we'll go over it in case anybody else is curious. It says, will we see separate pavement classifications in the future instead of a holistic ground classification? And Christina might have some more info on that, so if she wants to jump in, feel free. But I know that's something we've definitely been investigating. I've been working on different attempts at differentiating asphalt from the rest of the ground for quite some time. So I think it's definitely something to keep an eye out for. One note though, is it can get challenging depending on your environment. So some environments are somewhat easy to differentiate from the asphalt to the shoulder, but I've found some areas, and specifically I ran into in California, where they're using crushed asphalt as the shoulder material right into the asphalt shoulder. So it was kind of the same color, kind of the same level. It was really hard to differentiate and classify some of those scenarios, but we're still working on improving that.
Yeah, and I can add a little bit more information to that. So yes, we are looking at pavement classification, pavement isolation, more automatic ways to do that. But we want to do this in a meaningful way, right? Because you are not trying to classify pavement just to classify pavement, right? You want to use this classification for certain workflows, whether it's pavement inspection or maybe surface modeling. So we want to make sure that we're not just dumping a classification at you, which is, not very accurate, and you still have to do lots of manual corrections. We want to make sure that it integrates well with other workflows that you have. Definitely would be happy to chat about this in more detail. Currently, where we see pavement classification being quite useful is pavement inspection, ground surface modeling. It's very challenging because pavement looks in many cases sidewalks and the ground. But yeah, we are definitely looking into this.
Cool. Thank you, Christina. So that looks like that's our time. If there's any further questions, I'm happy to stay around for a couple extra minutes, but if not, I will stop showing the screen.
Yeah, so I'd like to thank everybody in attendance today. Thanks to Seiler and Christina. Really appreciate everybody coming out. We will be sharing a copy of the recording, and that'll be available in a couple locations. So feel free to share it with your colleagues that weren't able to attend today. And of course, if there are any questions that pop up once we're done here today, feel free to reach out to us in person. So thank you very much.